Let's take another look at this getRaise function back on slide 15. I wanted to point out that the order in which we did these dynamic casts was not arbitrary. If you have a hierarchy of classes and you want to try to identify which specific kind of class in that hierarchy a pointer is pointing to, you need to arrange your sequence of if tests from the most derived level down to the base class level. So here, since we have employee as our base class, and a manager is a kind of employee, and a CEO is a kind of manager, which is a kind of employee, we did our check for the CEO first. Then if it wasn't a CEO, we did a check for a manager, and if the pointer was not pointing to a manager, then we knew that it had to be pointing to an employee. Now, if we switch these around in the other order, and we tested for employee first, well, PE is a pointer to an employee. And so any PE that comes in is going to be an employee. And if we tested for an employee first, that test would always succeed. And we would not get down to doing the manager test or the CEO test. Okay? Because if PE is pointing at a CEO, since a CEO is a kind of employee, PE is also pointing at an employee. And so if we did a check whether PE was pointing at an employee, we would discover, oh, that's true. Okay, so the order in which we did this, from most derived down to base, is very important. Let's take a look at the last couple of items here. Type ID is sort of a nice miscellaneous operator to know about. Type ID gives detailed information about a type in a format that is specific to your compiler. Type ID produces something called a type info object, and in order to make use of that type info object, you have to include the type info header. You can have a look at the contents of type info and the type info data type online, but among other things, you can ask for the name of the type, which will give you a C language style string, that is a null terminated array of characters, providing information about the data type. Another thing you can do with type info is to use an equality test to see whether two objects are of the same type. Okay, so here on slide 19 we have a function named CMP types, compare types. CMP types takes two pointers to employees as arguments, and first gets the type ID information for the first pointer, and from that displays the compiler-specific name of that first type. Then we also are getting the type ID information for the object that PE2 points to, and displaying the name of that thing as well. Finally, we're using type ID with the equality test to see whether the data types of the objects that PE1 and PE2 point to are the same or not. Here on slide 20, we have a program making use of this compare types function. We've got Doug is a manager, Ed is an employee, Frank is a CEO, Gene is a manager. We've specified the names and rates for each of these objects, but we've used default values for any other parameters. So Doug has a default title and budget, Gene has a default title and budget, Frank has a default title, budget, profit target, and bonus percentage. Okay, so I'm going to call compare types, passing in the address of Doug and the address of Ed. Compare types receives these as pointers to employee, but type ID is smart enough to figure out the actual data type of the object that the pointer is pointing to. And so we're going to get the compiler-specific name of Doug's type through PE1. Then we're going to get the compiler-specific name of Ed's type through the pointer PE2. And then we're going to test whether these types are equal. Let's take a look at the output on slide 21. Okay, so PE1 is pointing at a manager, and my compiler's description of the manager data type is the numeral 7 and then manager. That numeral is simply the number of characters in the class name. So 7manager means that there are 7 characters, and those characters are manager. Then what PE2 is pointing to is an employee. There are 8 characters in employee, and we are told that these types are not the same. The type ID of star PE1, which is a manager, is not the same as the type ID of star PE2, which is an employee. Going back to our program, we next compare the types of Doug and Gene. This time, both Doug and Gene are managers, and so their type IDs are going to match. We get told that star PE1 is a manager, star PE2 is a manager, and these types are the same. Okay? Now let me display the program on slide 20 on the right-hand slide here. We're done looking at the CMP types function. If I ask for the type ID of CEO, notice that I can specify a type name rather than an object value as my argument in type ID. That will give me back the type info for CEO, and .name on my system is 3CEO. In other words, 3 are the number of characters in the class name, and the class name is CEO. In the second to last cout statement, I'm asking, gee, what is the type ID of the cout object, that is the standard output stream object? Tell me the name of that thing. And again, on my system, what I get is SO, which I'm interpreting to be stream output. But I would have to grovel around in some documentation somewhere to get a definite answer as to what that SO means. Now, CMP types is the function that we defined back on slide 19, and that we've called here a couple of times for Doug and Ed, and then later for Doug and Gene. We can ask, what is the type ID of that thing? And tell me the name, the C-style string description of that type. And what I get on my system is function, okay, capital F, returning void. The little v means that this function returns void. Let's see if that's true. Yes, indeed. CMP types returns void. And as its first argument, it's apparently taking a pointer to an employee. Okay, P for pointer, and then 8employee is the name of the class. Now, S0 underscore E, I confess I can't interpret without digging through some documentation. But the bottom line here is that type ID with the name member function will help you get some string representation of the data type of an expression or an object or a type.